16%, 19%, 38.7%, 12.9%. And we've got our relative frequency. All right, Zane.
Yeah.
Shape. Talk to me. What would you say about this one?
I would say that this is definitely unimodal.
Yeah, one main peak, okay.
It's skewed left.
Skewed left is correct. We're going to be dealing more with this. Remember how we did shape? We just drew a relative. I agree. From the major peak right here, we definitely have a lot longer tail on that particular side. All right, so what have we done last chapter? What have we done up to this point? Okay, anytime we've got a set of quantitative data, numbers, okay, we draw a picture. We learned a lot of different types of pictures. We learned dot plots, box plots, histogram, which is something we use almost always from this point on. Okay, and then we did analysis of it. We discussed the center, shape, spread, and outliers. Okay, so where are we going now? Okay, we're going to get more specific with the type of distributions we have. Tomorrow, we're going to learn about something called a normal distribution. I don't know if any of you have ever heard of normal curve or grading on the curve. You're going to get familiar with that. You're going to see it a lot in college. A normal distribution usually happens in real life a lot. Kind of looks like this. Okay, we're going to talk more about that tomorrow. Before we can get into this thing called normal curves, we got to get a little more specific and define this thing called a density curve. All right. A density curve. It's just this thing we've been drawing over our histogram. I need you to remember, because from now on, we're just going to be doing this all the time. All over the place. We're going to be drawing curves. I need you to remember that the density curve initiated from a histogram. We know some classes, we figured out how many were in class, we got a percentage, and we drew a histogram. So that's where all these curves came from. They came from a histogram. I need you to remember that. Now, second thing, this is the big thing I need you to remember today, is that the area under a density curve is going to equal 1, or 100%. Now let's take a look at this. Is the area under this curve right now going to be equal to 1? Well, how do we do this? Here's a rectangle. Let's just do this rectangle right now. How do you figure out the area of a rectangle? It's calculus freaks.
Length times width.
Okay, so it's length, base times height, length times width. So this is how long from here to here? 8. So 8 times, and then what's the height here?
30.
So how do I write that? 0.387. Somebody throw that in your calculator real quick for me.
That is 3.096.
So just the area of this is 3.096. So if I find out the area of all of these things, is it going to be equal to 1? No. Okay. So in order that every single one of our curves can have an area underneath the curve of 1, this cannot be relative frequency anymore. This can't be percentage anymore. We have to change it to something called density. Now, here's the deal. I'm going to show you this crazy math. We're going to do it here. Okay? I don't want you to ever have to do this. Okay? I just want you to know that, oh yeah, that one day, that's how we made the area underneath all these curves is 1. Okay? So this is what I need you to remember, and I just want to show you real briefly how they did that. How do I make the area of all of these rectangles into 1? Well, I'm going to create a third column, fourth column, and we're going to call it density. And this is how they define density. They take the relative frequency and divide it by the class width. So what were our class widths on all these problems? 8. Okay. So let's go ahead and do that. Take that relative frequency, 12.9, so that's 0.129, correct? Divide it by 8. And what do we get here? Now we're going to get pretty small numbers.
0.016.
0.016. Okay, that's good. 1.6%. Next one.
0.020.
.020.
0.024.
Next one, the big one. Oh,
0.048.
and then probably the last one, 12.19, that's .016. If you add all those up, what do you get? What?
1.
I want to try it.
No.
If you add all these up, what do you get, roughly?
.124.
No, 125 is correct. Okay, just keep that in the back of your head. 0.125 times 8 is, okay, that's how we're going to get this area to work, okay? So now we're going to create the same graph. Okay? Create the same graph. Okay, so this is still going to be our classes. But now this is going to go by density. This goes to up to about 0.05, so I'll go 0.1, 0.2, 3, 0.4, and 0.5. Okay, so I'm going to graph it against density now. What do you guys think this graph is going to look like compared to our original? Exactly the same. Now if you multiply the length times the width for each one of these and add them up, your area will be 1.
For the density column, is it 0.01?
Yeah, thanks. So now when I draw this curve, area underneath that curve will be 1. So from now on, whenever we draw a curve representing data, 2 things I want you to remember. Remember that that curve originally came from a histogram. And remember that the area underneath this curve is going to be 1 or 100%. All right, you had to last week get a shape like this and be able to talk about center. Remember, some of you are like, where's the center? Where's the mean? Where's the median? All right, we're going to clean that up on a density curve right now. Let's first talk about the median. Now, we know that the median is the 50th percentile. Half the data is above it, half the data is below it. That's what you find in here. You know that this now represents 100%. Or 1, so I want to get 50% on one side, 50% on the other. So you want to find the place where about half the area is here and half the area is here. I cheated, I knew your median was 72, but that looks like about half and half, right? So we have 0.5 over here, 0.5 over here, maybe it's a little bit more over. So that's how you find the median from a density curve, which came from a histogram. Now the mean is a little bit trickier. The mean is, okay, let's say this was a teeter-totter. Where would you put that fulcrum so that it would now balance? And to get a better example in this, go ahead and open up your books to page 82. You find the mean on a density curve by exactly where would that thing balance. If I've got a long old tail over here, I've got to put that fulcrum right in there so this thing will now balance. So you see three good pictures there on where you put the mean. On ours, your mean was around 70, 69.4. So I don't know, it's right about here. Could be, and because it's left skewed, right? I got a longer tail over here, so I move that little fulcrum over a little bit so that thing can balance. So it just kind of gives you a visual of where the mean and median. And are we surprised that the mean is less than the median?
No.
No. We said left skewed just looking from the picture, right? We know the mean will be less than the median. Okay. So now if you have a picture, you have a better idea of where to find the mean and the median from your picture. Okay. All right, as I said, these are kind of looking like normal curves. We're going to talk about that tomorrow, but right now I want to talk about another special kind of distribution, density curve. And it's called a uniform distribution. Looks like this. What kind of a distribution chart would end up with that kind of a curve? What kind of a distribution chart would end up with that kind of a curve? What kind of a chart like this, what kind of a distribution chart, what would this thing look like that would end up giving us a density curve that looks like that?
All the classes would have the same amount.
Yeah, what if everyone, I got 5 students here, 5 students here, 5 students here, 5 students here. Wouldn't that create a histogram where all the rectangles were exactly the same height? That's what we have here. That's called a uniform distribution, where all of the outcomes are equally likely to happen. These percentages would all be the same. All right, you're going to play around with some density curves. Now, this is a density uniform distribution. Density curve, that's your hint. So I don't know, let's say I've got a number line down here. Here's 0, here's 1, and here's 2. How high is this? On the density scale here. How high must that be? Now remember, this is a density curve. It's your hint.
A half?
How'd you get that?
Because it has to equal 1.
What has to equal 1?
The area under the...
Remember, isn't that the definition of a density curve? The area underneath there has to be 1. What shape is this? This is a rectangle, right? So 2 times what gives you an area of 1?
Yeah.
0.5 or 1/2. You're going to do a problem tonight. There's a couple of things that I want you to practice on. Your density curve tonight is going to be a little bit simpler. Okay, it's just going to go from 0 to 1. Okay, so how tall is this one going to be? Okay, then it's going to ask you, find the area between 2 spots. So let's say I want to find the area between 0.2 and 0.8. Now this is what I'm going to want you to do. In fact, take a look at the problem you're going to be doing tonight. This is what you're going to be practicing. It's number 2 on page 83. You've got your B through E, or actually A through E. You're going to draw this, this is what I'm going to be looking for tomorrow, 5 times. You're going to draw this picture 5 times. But what I want you to start practicing is I want you to shade in the region, okay, that they're asking for. So if they wanted to know the area between 0.2 and 0.8, it'd be like me asking, hey, you know, what percentage of scores were between 56 and 80? Okay. So what I want you to do is to go, here's your 0.2, here's your 0.8. I want you to shade it. So show me the region I'm talking about. And now let's go find the area to that region. What would it be? How far is it from here to here? 0.6. How tall is it? 0.6 times 1. 0.6, 60%. Yeah.
I thought you said the area under the curve has to equal 1.
It does. The area under this density, under this uniform distribution, the whole rectangle is 1.
Not for parts of it.
Okay, no, not for parts of it. The area under this whole curve is 1. What I'm like asking you to do now is just tell me the area between these two spots. But you're just doing it on a density curve. So tonight I'm going to see 5 different pictures. Draw it once, then draw it again for B, draw it again for C, but make sure you shade that particular region. Yeah.
So you multiply the distance in between. And then
What shape is this?
A rectangle.
So how far is it from here to here? Right, so you can just subtract those two and go from here. Now I got a little bit trickier one for you. Turn the page. That is also a density curve. The one on top there. This is like the last day we got these crazy density curves. They all look like the ones on the bottom starting tomorrow. But this is kind of the last crazy density curve you'll have. So the first thing that you're asked to do is to prove that this is in fact a density curve. So you need to prove that the area under that thing is equal to 1. We'll break it up into sections. You got a rectangle on the left, rectangle on the right, and then I see a triangle. Does anybody remember the formula for a triangle? Yeah. So you got some different things. Go get the different regions, add them up. They better add up to 1. Then on the other problems, again, I'm going to want you to draw that picture 4 times. So you've got your crazy looking density curve, right? And if they want to know, I don't know, between here and here, shade that region, and then go figure out what the area under that region is. So you might have to deal with triangles, you might have to deal with rectangles. Okay, but go find out what that is. Okay? This is when my head's going to spin off tomorrow. Okay? I'll come around to your desk and I don't see these pictures drawn multiple times with shading. No credit. Okay, you'll see why this is important starting tomorrow. Yeah?
Can we make these a little bit smaller than we usually would so that they're more...
Yeah. Biggest one. All right, last thing. Got some new symbols for you today. I'm going to define what these are much better in about a week. Okay, but for right now, let's just kind of learn what these are. The first one is the Greek letter mu. Okay? Whenever you see this symbol, I want you to think mean. Now, what's the symbol that we have for mean right now?
X.
X bar. Okay, so now you got 2. You see X bar, or you see this crazy looking thing, it means the average of the numbers. Okay. This guy you've seen before, you've seen it on your calculator, haven't you? It's a Greek letter sigma, and it represents the standard deviation. So now you have S and you have sigma. For the point of what we're just doing today, we're going to use these symbols when we're dealing with a density curve. So if we have a density curve, in other words, the area underneath the curve is 1, okay, and we're asked to figure out what the mean is, we're going to use the symbol mu. And if we're asked to figure out what standard deviation is, we'll use the sigma, the symbol sigma. Okay? Bunch of stuff today. Here's the biggie, okay? From now on, we're going to be drawing density curves. I need you just to remember it's equal to 100% underneath. Okay, we know where to find the mean and median now on a histogram. First weird-looking distribution that we've got is called a uniform distribution. Okay, you're going to play with that tonight. And a couple of new symbols. Okay, any questions, comments?